Good evening, good evening, good evening once again. Okay, so this is one more problem which many students I see they make a mistake. An ideal gas of n molecules is maintained at a constant pressure P. Okay, the graph shows the volume V of the gas, which varies with absolute temperature T. So when I say absolute temperature, it is nothing but your in Kelvin. Okay, so what is the gradient of the graph? See, problem appears to be very straightforward. We know PV equal to nRT, where n is the number of moles. And then directly we can write V by T, V by T, PV by T. I'll pull this T downwards, divide by T on both the sides. So that I get the answer as N into R. And I'll push this P downwards. So I get this answer as NR divided by P. And then I think, yeah, this N is small n. Maybe I should have used this capital N. See, this capital N is here. So therefore B is the right answer. Okay. 98% of the students make this mistake. Now, let us look at what is the problem here. Now, this n has some significance. What is this n here? N here is number of molecules. N here, right? And what is this n here? This small n is the number of moles. Now, how do you calculate number of moles from number of molecules? You have a relationship namely n is equal to n divided by Na. What is n by Na? N is the number of molecules divided by Na is the Avogadro number. Okay. So what we'll do is let us take up this equation. Once again, which equation? This equation. Okay. So therefore, V by T is equal to NR divided by P. And instead of N, I'll substitute this value. NR divided by Na. I substituted N equal to N by Na into P, which would now be equal to N into this R by Na. What is R by Na? R by Na divided by P. I am grouping this. What is R by Na? Now we know that the value of R can be written as Na times Kb. Have you learned it? Right? So where did you learn this? In gas equations only, where Kb is a Boltzmann constant. If you divide this gas constant by the Avogadro number, you will get Boltzmann constant. Right? So therefore, I will now substitute this and use this equation. And thus I will write V by T is equal to N Kb divided by P. Okay. Now this is V, this is T. So therefore, now the gradient here, this is C, this is V is nothing but Y here, right? V is along the Y axis. T is nothing but X axis. This should be equal to some constant N Kb by P. N Kb by P, or I can now say Y is equal to N Kb by P multiplied by X. Right? Now see, this equation resembles your Y equal to Mx, which is nothing but Y equal to Mx. This equation, Y equal to Mx. Right? If I extend this backwards, it will join at the value of the origin O. So therefore, which is the slope, which is the gradient here? The gradient should be N Kb by P. So the right answer should have been C. But unfortunately, what most of them do? They consider B is your right answer. I hope you got the problem, you got the solution, okay, and how to solve it and where is your mistake. Okay, this misconceptions, okay, can be solved. Such kinds of misconceptions can be solved provided you understand every term in the equation. Okay, if you know what does every term code for, then definitely you are passing your exam. But unfortunately, if you think that small n can be replaced by capital N, that's where your mistake lies. Okay, so with this, let me stop here. And if you like this video, do share and subscribe to my channel. This would really help me and encourage me to do more such videos.